So we've talked about carbohydrates, we've talked about fats, oils, and now we'll move on to proteins and vitamins. Again, just a brief introduction about this. And you've probably heard proteins are one of the building blocks of life. They're important for structure, for functionality. They're either used in the part of the enzymes, they're hormones, antibodies, and as we'll see later, they're made up of our 20 amino acids. Most of them we can produce, but some we have to get through our food that we take in. And like I said, they're made up of amino acids, which has 4 groups attached to the carbon. The carboxylic acid, which we talked about, which is the CH double bond OOH group, carboxylic acid. It has an amine group, hydrogen, and a side chain. And these side chains are designated R. There's 20 different side chains, which we'll show in the next slide. These are the ones that are naturally occurring. So we have these non-polar side chains. So all of the amino acids have this, as we just mentioned, hydrogen, amine, carboxylic acid. But it's these R groups that differ. And they've categorized it in non-polar side chains. Non-polar means they will not react well with water because non-polar likes non-polar and polar likes polar. So here we have in the polar group, we have some amino acids that can accept hydrogen. And these are our lysines, arginines, and histidines. So you can either name them or give them the 3-letter designation. For instance, histidine is HIS or just H as well. So those are our basic amino acids which accept the hydrogens. So when you accept the hydrogen, you get plus. And you have basic ones which will give off the hydrogen. So here we have, the acidic ones, which will give away the hydrogens. So at physiological pH, they will give away the hydrogens and you'll have these negative charges. And the 2 acidic amino acids are aspartate, aspartic acid, or glutamate, glutamic acid. So yes, acidic versus the lysine, arginine, and histidine with the basic. So these are the 20 amino acids again, and they are the building blocks, or they compose for peptides, which can make proteins. And here just reinforcing the idea that amino acids has side chains, which are both polar or non-polar. The non-polar groups, they don't like water, and we have the polar groups that like to interact with water. Also, these hydrophobic groups, they interact by intermolecular forces, which we talked about earlier in a previous model. We also have these polar side chains, and they can interact via hydrogen bond. Remember, the hydrogen of one reacts with the oxygen of another. You can also have nitrogen or fluoride as well. And these are usually found on the acidic or basic groups. Remember, our basic amino acids are the arginine, lysine, or histidine, and our acidic are the aspartic acid or glutamic acid. When 2 amino acids come together, just like the glycosidic bond, water is a product. So here you see the peptide bond here, where the OH, the carboxylic acid, reacts with the H of the amine, hence amino acid. So these two will react and give us our water product, and we have a peptide bond forming. And this happens over and over again, and you get these long chains of amino acids. And these are called peptides, which is composed of amino acid residues. So proteins can be, structure can be a primary structure where the amino acids are linked together by peptide bonds. You can have secondary structures as well, where there's interaction between the atoms of the polypeptide backbone through hydrogen bonding. You have alpha helices and beta sheets. We also have tertiary structure, where you have a three-dimensional shape here. And you can also have quaternary structures for proteins, and that's when polypeptide chains form and come together to make more protein complexes. But going back to the amino acids, the sequence of amino acids is very important because it helps define structure and functionality. Things like disulfide bonds can occur to help fold and denature proteins. As I mentioned earlier, you have these essential amino acids, those that can't be synthesized by humans. Maybe you've heard of when you eat turkey, there's a tryptophan. That's one that you need to consume. Also things like lysine, histidine, and methionine. Those are some where they're not naturally occurring in the body, where you have to eat to get. So now we have talking about vitamins, which are essential for us. There are 13 essential vitamins. You know this: vitamin A, C, D, E, and K. B as well. There's different types of vitamin B, like riboflavin, niacin, and a few others as well. And they are both water soluble here. So vitamin C is water soluble. You have those that are also fat soluble, like vitamin A. And they're really they're needed for cell function, growth, development as well. And they are organic compounds, as you can see. We also have these inorganic minerals, those that are not organic, not carbon. We talked about these already, like these called macro minerals in group 1 and group 2 of the periodic table. We have some micro minerals, which can be found in the transition states, and these are usually charged. We know this: the sodium and the potassium have the +1 charge. You've also heard drinking electrolytes, which helps replenish your body when you do sporting activities. So these are really important for metabolic and structural function. So those are just some of the things that I wanted just to touch upon for you. I didn't go into too much detail, whether it was with vitamins and minerals, proteins or fats or carbohydrates. And we'll move over to the next point, which is our food.